Okay, here's another application, example 2 from page 71, another application of the squeeze theorem. This time you have the function sine of x over x, and you're concerned with the x value approaching infinity, the limit of this function as the x is getting larger and larger. So let's see what we could do with this one. Okay, we know, once again, we can start with this step. We know that the sine value will always be in between. The range values for the sine function will be in between -1 and 1. Okay, the graph will oscillate once again in between -1 and 1. And in this time, we're concerned with sine of x being divided by x. So, using the division property of inequality, I could divide everything by x. And this inequality still holds true. And we're assuming that the x value is positive. So now, let's see what we could do. We could take the limits of each as x is approaching positive infinity. So this should be, in theory, less than the limit of sine of x over x, which should be, in theory, be less than the limit of 1 over x as x is approaching infinity. And then we already saw from earlier that the limit of 1 over x as x is approaching infinity is 0. And the likewise is true for limit of -1 over x as x approaches positive infinity. So by using the squeeze theorem once again, you see that the limits of sine of x over x as x approaching positive infinity must be 0. Okay, let's check this graphically. Okay, so now let's go to decimals again. Okay, so this time let me write sine of x divided by x. Oops, that's not right. Okay, sine of x divided by x. And there's my graph. And as you can see, if you're approaching positive infinity, again, your y value is approaching 0. Okay, so that is your answer for that one. I would recommend you to look at page 71's property of limits as x approaches positive or negative infinity. It's pretty much the same properties that we saw from lesson 2.1. Okay, the application of those properties is that you're able to split up the limits if you need to. So for example, you could split this up as 5x over x plus sine of x over x. And then in turn, the limit of a sum will be the sum of the limits. So you could write that as the limit of 5x over x plus the limit of sine of x over x as x is approaching positive infinity. For the first case, the x's will cancel out. You just have a limit of the constant 5, which means the answer for that is 5. You can't take a limit of a constant, it's just the constant itself. And the limit of the sine of x over x as x approaching infinity, we just saw that was 0. So your final answer will be 5. So the answer to this question would be 5.